Whenever we use a for loop, we can literally put anything inside its indented code block. Within a loop, we can print, we can do variable manipulation, conditional statement. We really have complete freedom as programmer. But what if I put another for loop inside a for loop, which results in a nested for loop? Loop inside loop. And this is when things starts to get interesting. For me, frankly, there's something unsettling looking into a nested for loop. What exactly happens? Most people have this intuition about a nested double for loop, saying, well, if a single loop is all about one loop variable hopping over each element of its iterable, then a double for loop must be about, well, there are two different loop variables, then two different loop variables are simultaneously running over two iterable. And unfortunately, this intuition about how double for loop works is just incorrect. So, what is the true behavior of a double for loop? Remember that there are two loop variables, vout for the outer loop and vin for the inner loop. The vin needs to complete its entire trip for vout to only advance by one step. Or you can imagine this. Every time when vout takes one step forward, vin needs to complete its entire loop. vout takes another step forward, vin completes another trip. So when the outer loop terminates, the inner loop has been iterated over many times. At least for me, this behavior is slightly unexpected. This is important. Let's watch this again. So if we were to look at the output generated by the print statement here, it's going to look something like A1, A2, A3, A4, A5, B1, B2, B3, B4, B5. You kind of get the point. You also notice the value of the outer loop variable is persistent for the entire duration of the inner loop. This outer loop variable, which currently is D, is used to concatenate with every single inner loop element before it expires and advance forward to become E. Despite its complexity, nested for loop is used inevitably in programming, such as matrix multiplication and dynamic programming. But today, let's just focus on a very simple application. Suppose I'm coding a poker game, so the first thing I need to do is to create a deck of 52 cards, which is conveniently represented as a Python list. I'll just manually add each card in there one by one, append 2 of hearts, 2 of diamonds, clubs, and spades. And after doing this 52 times diligently, I'm done with my deck of cards. But this just doesn't feel like the most efficient way of doing things. I could make the observation that a poker deck only has 13 different rank and 4 different suits. The formation of a deck is just each rank, take 4 different versions of suit. It's just combination. And this looks suspiciously like a double for loop. Therefore, I can write my Python code as, I have my outer loop iterating through all ranks, the inner loop iterating over each suit, and a card is simply the concatenation of a suit and rank, and I append the card to my cards. And this double for loop will get my deck of 52 cards. At this point, it's totally okay to feel nested loop is kind of hard. Absolutely. Especially if it's your first time seeing this. Compared to a single for loop, the complexity of double for loop is in fact not double, but square. Unfortunately, things can even get harder from here. Let's take a moment to compare the two different programs here. Can you spot out why the code on the right is much more difficult to understand? Feel free to pause and ponder. Alright, if we look at the left program, the inner loop always loops over from the range 0 to 5, independent of the outer loop. On the contrary, the right one, the inner loop is iterating over range 0 to I. But what is I? I is the outer loop variable, which means it changes through the execution of the program. The iterable of the inner loop depends on the outer loop. There is a fundamental dependency between the two loops. So what does that look like? When the outer loop just begins, the loop variable I binds to 5. According to our program, the inner loop needs to take a trip from 0 to 4. As the inner loop terminates, the outer loop takes one step forward. I is now 6, which means the inner loop needs to iterate from 0 to 5, which is one more than its previous run. I binds to 7, the inner loop goes from 0 to 6. I binds to 8, the inner loop needs to go from 0 to 7. I binds to 9, the inner loop needs to go from 0 to 8. So you already see the pattern. As the program executes, the extent in which the inner loop needs to iterate also increase. The behavior of the inner loop, how much work it does, is dependent on the outer loop. Why would a programmer ever use a nested loop that has dependency? Well, remember from last chapter, we learned about factorial. If we want to compute the factorial of integer n, we use a for loop from 1 to n, iteratively multiplying each number and accumulate into p. However, what happens if someone throws me a list of integers and asks me to compute each one's factorial? What should I do? Let's look at this again. This block of code computes the factorial of n, and n is a variable. I can change n to 11 and see that the factorial of 11 is a big number. So why can't I change n into a loop variable iterating over a number list? And we just migrate this entire code block inside, of course, indented. Notice we have a nested loop with dependency of the inner loop range from 1 to n plus 1. The mission of the outer loop is to iterate all integers from this given list. The mission of the inner loop is compute the factorial of that corresponding n. Execute. Great. There is one detail to point out. Notice on line 2, p equal to 1, is in between the outer loop and the inner loop. This means that every time when the variable n takes one step forward, rather than launching the inner loop immediately, the first thing it does is to reset p back to 1, then follows the entire inner loop. This reset is critically important because when the inner loop is calculating the factorial, the value p gets pretty big. As the outer loop takes one step forward, we need to reset p back to 1, so the residual from the previous inner loop does not linger over. Loop is the most important concept in the basics of programming, which is why we spent 3 chapters on this topic. We start learning about loop from a visual approach. We see with our eye that the loop is really running. In part 2, we learned about how to loop with range. And today, we saw the unexpected complexity of a nested for loop. In terms of big picture of essence of Python, we have already added these items to our toolbox. Variable manipulation, which is a unit of compute, conditional statement, decision making, Python list, data structure, for loop, automation of logic. These combined may only occupy 20% of Python's programming feature and syntax, but the core concepts are definitely relevant in at least 80% of any programming thinking. An interesting note aside, when Vitalik was developing the next generation blockchain, Ethereum, he was especially aware about the feature of loop. He realized that Bitcoin's foundational limitation is that it doesn't allow loop. So he added loop in Ethereum, which enabled it to become a versatile platform for developers to make interesting applications. Our journey, however, is far from over. Next chapter, we'll explore what is the essence of a function and how it's really not a function you'll recognize from your math class.